Okay, so here's a really nice simple example showing you how you can use the factor theorem to answer a question. Okay, show that x minus 2 is a factor of x cubed plus x squared minus 4x minus 4. Now, one way you can do it is to use long division, which I'll come on to in a couple of minutes. Okay, but what you can do is quickly answer the question using the factor theorem. Okay, because if x minus 2 is a factor of this, that has got to imply that x equals 2 is a root. That's what this is saying, isn't it? Okay. So if x minus a is a factor, this implies that f of a equals 0. So it implies x equals a is a root. So what I'm going to do is I'm going to call this f of x. Okay. And what I'm going to do is I'm going to substitute x equals 2 into this polynomial. Okay. And this is the shorthand way of doing it. Rather than write when x equals 2, this is equal to whatever, it's best to say that this is f of x and we're going to substitute x equals 2. And you can't just write down 0 because you've got to show working. It's a show that question, so make sure you show sufficient working to be able to justify your answer. Okay, it's a little bit like a proof, really. Okay, so you write it out as 2 cubed plus 2 squared, subtract 4 multiplied by 2, subtract 4. In other words, you literally substitute x equals 2 into all of that and writing down what you get. So 2 cubed is 8. 2 squared is 4, and then subtract 4 times 2, subtract 8, and then subtract 4. And then you can write down that equals 0, because it is, isn't it? 8, subtract 8, and 4, subtract 4 equals 0. Okay? And then, because it's a show that question, you've got to give a conclusion. You've got to say, therefore, x minus 2 is a factor. And that'll do. If you want to be complete, okay, just write down is a factor of this. I'm just going to write is a factor of f of x, like that, okay? And that's enough. That's enough to do it, okay? You can do the same using long division, okay? And I'm going to show you a method in a minute, but what I'm going to do is I'm going to tell you what reason we might have to do this. Sometimes you want to be able to factorise this. Remember I mentioned this in the long division videos I showed you earlier. Sometimes you want to factorise this, and what you want to do is use the fact that it is one of the factors to find the other factor, in which case long division is the method you want to go for. So sometimes this question is followed up by a part B, and the part B might be hence factorise this completely. So let's have a go at that. I'm just going to put this away for the moment. Okay, and let's just see if we can do that. Okay, so what I'm going to do is I'm going to use long division to do it. So I'm going to set it out like this, and I'm just hoping that despite its long division, I've got enough room here. The polynomial is not that long, so it should be fine. So x cubed plus x squared subtract 4x subtract 4. Okay, and I'm going to start the process. So this is a bit of a recap for you. Okay, so x times x squared gives us x cubed. X squared times that gives us x cubed. Subtract 2 x squared. Find the difference. That subtract that is 3x squared. Bring this down. So subtract 4x. And then x times 3x gives us that, so plus 3x up there, 3x times this gives us 3x squared, subtract 6x, and then do the subtraction, negative 4 plus 6 is 2, so 2x, bring down the negative 4, and then x times 2 gives us 2x, so plus 2, and then 2 times x minus 2, so 2x minus 4, and the difference between that is 0. Okay. Incidentally, that's another way you can do the show that here. Show that x minus 2 is a factor. If you go through the long division process and you get 0 as a remainder, that's an alternative way of doing it. Okay. However, if that's all the questions ask you to do, if all the questions ask you to do is to show that this is a factor, notice this is a more time-consuming way of doing it. Okay. This, in just a couple of lines, is much, much simpler. Okay. But if you did do it this way, you just have to end with the same conclusion. Okay. But what I'm doing is I'm actually answering the potential second part of the question, which is to hence factorise this completely. Well, you can do it. Now you see the other factor's got to be x squared plus 3x plus 2. Okay. If you don't mind, I'm just going to find my board rubber again and rub this off. Okay. And I'm going to write down by here that you can factorise this f of x as x minus 2, and the other factor is this x squared plus 3x plus 2. So the long division process has actually helped us to be able to factorise that. But if you're asked to factorise it completely, just check to see whether this quadratic can factorise again. I think it can do, don't you? So you've got x minus 2 here, because that should be able to factorise as x plus 1, x plus 2, like that, yeah? And so now we've factorised the whole thing completely, okay? I hope you found that useful. But before I go, I'm going to show you an even quicker way of being able to factorise this, okay? So let's just go back to this, show that x minus 2 is a factor of this. Well, let's assume that's been done, okay? If you're asked to factorise this, how can you do that quite quickly, okay? Well, I'm going to write down the answer down by here, just so we don't forget. It's the quadratic, which is the crucial bit, okay? How do you factorise this thing without using long division? Okay. What you do is this. Well, you begin with, okay, you've got the cubic f of x, x cubed plus x squared minus 4x minus 4. How do you factor? Well, we know that x minus 2 has got to be one of the factors, okay? And what I'm asking to do is work out what the other factor is without using any long division working. Well, you can deduce that the first term here has got to be x squared, yeah? Do you know why you can deduce that? It's because when you expand the brackets, you need to get x squared times x cubed there, okay, so that works. And what I'm going to do down here is I'm going to show you some additional working. I'm going to expand what I've got so far. So I've got x times x squared, which is x cubed, and I've got negative 2 times x squared, negative 2x squared. But what we want is we want plus x squared to be our next term, okay? So what we're going to have to do is we're going to have to add on 3x squared somehow, aren't we? So that combined is going to give us the plus x squared that we want. So the term that goes here has got to be such that we get 3x squared out of it. Can you see what we need? We need plus 3x there, okay? Because when we do 3x times x, that gives us the 3x squared that we want. Let's continue to expand the brackets. What we've got so far, negative 2 times 3x is negative 6x. But what we want is we want negative 4x, okay? So somewhere we're going to have to do plus 2x, so that these two combined gives us negative 4x. And the way to do that is to have the plus 2 here, because then you've got 2 times x, which gives us the plus 2x we need. And then when you finish off the expansion, negative 2 times 2 is negative 4, which is what we wanted, okay? And then we've actually done it, okay? I'll take you through that process slowly, but when you practice those on your own, it's actually quite quick to do. Of course, yeah, I've wrote that down there just to check that we were getting the same answer, okay? And then if it was to factorise completely, obviously you can do the x plus 1, x plus 2 again, okay? If you didn't like that method, if you prefer the long division, fine, that's great. But what I'm trying to do is I'm trying to give those people that can actually use this method and are comfortable with it a chance to be able to answer questions a lot more quickly, okay? Right, hope you found that useful. Okay, so here's a factor theorem example, okay? Given that x plus 1 is a factor of 4x to the 4 minus 3x squared plus a, find a, okay? Now, a reminder of the factor theorem. So here it is, x minus a is a factor of f of x. That implies that f of a equals 0. So using that then, x plus 1 is a factor of f of x. So what that means is that f of negative 1 must be 0. Okay, see how that works? So what we need to do is substitute x equals negative 1 into that and write down what we get. So negative 1 to the power of 4 is 1 times by 4. And then this one here, negative 1 squared is also 1. And then times up by negative 3, and then plus a. Remember, of course, that we want f of a equals 0, so f of negative 1 is equal to 0. And that's how we've used the factor theorem with this. So all that means we have to do is just rearrange this. 4 subtract 3 is 1, so a must be negative 1. Okay, and it's done. So what that means is that our polynomial here, f of x, is 4x to the 4 subtract 3x squared subtract 1. So that's what the polynomial actually is, okay? let's go one stage further, okay? What if now we had to factorise it? What if we wanted to factorise it? I want to factorise it. Do you want to factorise it? Yeah, I want to factorise it, okay? So what I'm saying is that now that we know what this actually is, and because we've got x plus 1 as a factor, we can go ahead and factorise this. So what that means is we can write it as x plus 1 multiplied by something else. Okay, it's our job to work out what that factor is. There's two ways of doing it. You can use the long division approach. So you just do that divided by x plus 1. And if you do that, don't forget to put in a 0x cubed term and a 0x term, because those are missing from this, and that will mess up your subtractions in the long division working. Okay, so if you use long division, don't forget to do that. I'm not going to use long division, I'm going to do it by inspection, okay, because I prefer it that way. So what I'm going to do is I'm going to use inspection to work out what goes inside the brackets. I'm going to deduce that, okay? And the first thing I'm going to notice is that the first term is going to have to be 4x cubed. Do you know why that is? Because we're going to have to get 4x to the 4 there, and obviously 4x cubed times x is 4x to the 4, okay? And my method is, as I'm doing it, as I'm going along, I will expand everything that I've got so far. So x times that is this, and 1 times that is 4x cubed. I'm going to rub off that bracket there because I think I'm going to need a few more terms. Now, we don't have an x cubed term there, so clearly we're going to have to find some way of subtracting the 4x cubed in order to make that 0, okay? So for my next term, I'm going to need something so that I get subtract 4x cubed, okay? And that's going to be subtract 4x squared, because notice when I do that times that, that'll give me the negative 4x cubed, okay? And continue the expansion, 1 times that will give me negative 4x squared. And looking to see what I want. I want negative 3x squared. So that means is we're going to add on x squared in order for those to combine to get negative 3x squared. So in considering the next term, I'm going to have to decide what I need in order to get plus x squared. So if I have plus x there, that would work, wouldn't it? Because x times x is x squared. Continue through, 1 times x is x, and looking at the x terms, I don't have any x terms, so I'm going to have to find a way of subtracting x again so that they will combine to get 0. And how am I going to do that? If I want to subtract x, I want to have a subtract 1 there, because then that will give me subtract x. Following it through, 1 times negative 1 is negative 1, and yes, that's what I've got. And that's it. So you can check that, but if you expand the brackets, this is what you get. You get this, 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 this. And because those combine to get 0, those combine to get 0, those combine to get negative 3x squared, that gives us what we're after. That gives us what we want, okay? So there we go. Quite nicely done. And if you did do the long division method, hopefully you got 4x cubed minus 4x squared plus x, subtract 1, okay? So that factorises nicely like that, okay? Does it factorise any more? Does it factorise any more? Well, I'm going to use an inspection method for this. Okay. What I'm going to do is I'm going to look to see what value of x could make all of this equal to 0, because that's how you can see what another factor is. That's, again, what the factor theorem is. If you find a value of x that makes a polynomial equal to 0, then you found a factor. Okay. Now, because of the 4 and the negative 4 and the x and the negative 1, I'm going to try in this to see what happens when I substitute in the value of 1. Okay, I'm going to get 4 times 1, subtract 4 times 1, plus 1, subtract 1, and yes, that equals 0, doesn't it? Okay, so all that means is within this, I know that x equals 1 is a root. So what that means is that x minus 1 must be a factor of that, okay? X minus 1 must be a factor of that, okay? So that means I've got x plus 1 there, and then this cubic will factorise with x minus 1, okay? And then there'll be a quadratic in there. I'm going to use the inspection method again to work out what that quadratic factor is. If you use long division, go ahead, okay? You've just got to do that divided by x minus 1, okay? I'm just going to use the inspection method, okay? If you want, just have a race, see if you can do it quicker than me, okay? You use your long division method, see if that works quicker than me when I'm doing the inspection method, okay? Just bear in mind, I'm going slowly and I'm going to be talking through it as well, but it's up to you, you can do that if you wish, okay? Right, you can go now. So I know the first term here has got to be 4x squared. Mute it if I'm disturbing you while you're doing your work, okay? And so x times 4x squared gives me 4x cubed, and then the one time, negative 1 times negative 4x squared. Lovely jubbly. Okay, sorry for that if you're not a Londoner. I'm not a Londoner either, I just don't know why I like only fools and horses. So that gives me, I've already got that, which is great. Okay, so I don't have to worry about that term anymore. Okay, what I do need is I do need a plus x and a subtract 1. Well, quite simply, if I have plus 1, that would work, wouldn't it? Okay, that would work, wouldn't it? Because then I have plus x there, and I have subtract 1 there. So actually, quite quickly, I found it. You probably didn't beat me on the long division thing, did you, if you tried it? Because that was actually a quick one, I wasn't expecting that. But there you go. That's our full factorisation. And 4x squared plus 1, that's not going to factorise anymore. Okay, so there we have it, that's our polynomial, completely factorised. X plus 1, x minus 1, 4x squared plus 1. Okay, hope you got something out of that. Okay, hope that that all made sense to you. Remember, the good thing about these videos is you can always rewind it and have another look at it again if you want to see that for a second time. Okay. Okay, let's take a look at this example. We've got f of x is p, x cubed plus x squared minus 19x plus p. Given that 2x minus 3 is a factor of f of x, find the value of p. And then factorise f of x completely. Okay, so again, this is using the factor theorem. That is, x minus a is a factor, f of a equals 0. But this video, okay, we're going to be using this. Okay, so ax minus b is a factor, so f of b over a equals 0. Okay, so what that means is that 2x minus 3 is a factor. That means we want f of 3 over 2 is equal to 0. Okay, in case you can't see that, then just have a look at this. Okay, so you've got 2x minus 3 is a factor. That means you could set 2x minus 3 equal to 0, and then you've got 2x equals 3, your x equals 3 over 2. You can just do it that way. What most people do is they just do the 3 over 2. Okay, whichever way you do it, memorising this, you just need to know that 3 over 2 is what we're substituting in. Okay, right, let's have a look and do that. Okay, so this is f of x as put in. So we've got 3 over 2 cubed, so that's going to be 27 over 8 times by p, yeah, and then x squared, so that's going to be 9 over 4, so plus 9 over 4, and subtract 19x, so subtract 19 times 3 over 2, so that's going to be 57 over 2 plus p, and that is equal to 0. Okay, and we're going to work out the value of p is from there. Should we go for common denominators with this? Might be an idea. So 27 over 8 p plus, that would be 18 over 8, and that would be subtract, times that by 4, 57, 114, 228 over 8, okay, and then plus p. Should we write that as 8p over 8? Yeah, equals 0. Or if you didn't want to go for the common denominators, you could have just multiplied both sides by 8 if you wanted to. I'm going to do that now. The next step, multiply both sides by 8. What we're going to get, let me do it the quick way. So times this one by 8, we get 27p. Times this one by 8, we get 18. Times this by 8, we get negative 228. Times this by 8, we get 8p equals 0. So yeah, that's it. And then simplify, so 27p plus 8p, that's going to be 35p, okay? And then 18 subtract 228. If we put it onto that side, that would be 228 subtract 18, so that would be 210. Okay, so 35p equals 210. So P is equal to, well, notice that if you double that you get 70, and 70 is an easy one to go into 210 because 21 is in the 7 times table. So 70 times by 3 we give that, so that means that'll give you 6. Okay, it's just my weird way of actually working out what P is. Anyway, I'm sure you can work out that 35 times 6 is 210. Okay, so that's it. The value of P is going to be 6. So in terms of factorising it completely, what we're going to do now is we're going to rewrite it. So I'm just going to rewrite the top one as 6x cubed plus x squared, subtract 19x plus 6. Okay, and we're going to factorise that completely using 2x minus 3 as one of the factors. Okay, hopefully you're happy with this. If not, just rewind the video, watch it again, or just freeze frame it, whatever you need to do. But I don't need that anymore, do I? Okay, because I'm now on part B, factorising this completely. Okay, so we've got f of x, let's write it here, 6x cubed plus x squared minus 19x plus 6. That can be factorised as 2x minus 3 multiplied by something else. Okay, we've got to work out what something else is. Now you can use long division if you want. Okay, and to do that you just do this divided by 2x minus 3, and it should give you a quadratic answer. I'm not going to do that, I'm going to do it using what I call the inspection method. Okay, so that is by inspection. I know that this term here has got to be 3x squared, because 3x squared times 2x, of course, gives us 6x cubed. And then continue with the expansion, negative 3 times that is negative 9x squared. And how does that fit in with this? Well, I want plus x squared, so that means is we're going to have to add on 10x squared, aren't we? Because we want those to combine to get positive x squared. Okay, so for the next term I want to get 10x squared, and we're multiplying that by this, so that means that must be plus 5x, because 5x times 2x gives me the 10x squared. See how that works? And then continue the expansion. Negative 3 times that is negative 15x. Let's see where that fits with this. We want negative 19x, so we're going to have to subtract another 4x, so that that combines to get negative 19x. So this next term I want to multiply by something in order to get negative 4x. And so that's going to be subtract 2, because 2x times negative 2 will give us the negative 4x we need. And then continue the expansion, negative 3 times negative 2 is positive 6. Which is that. And so we've done it. Okay. Hopefully if you did it the long division method, then you'd have got the same, 3x squared plus 5x minus 2. Okay. It's just that I'm assuming that because of the previous videos I've shown, and because of the, well, the extra practice you'd have hopefully done from the exercises in your textbook, you'd be happy with the long division. Happy enough for me to not have to work through it all over again. But anyway, that's what you should have got. Now it does say factorise completely. Look out for this word, factorise completely, because what that means is you've got to check to make sure that this can factorise again. If it doesn't, then that's your final answer, but if it does factorise again, then you've got to work through it. Okay. A quick way of checking whether it factorises to use the discriminant. Okay, maybe if I remember I'll show you that in a minute, but I got a strong hunch that does factorise. Okay, so I'm going to just get straight into it. So 2x minus 3, and it will factorise into 2 factors like that. Now because of 3x squared there, it's going to have to be 3x and x, isn't it? Okay, and the number negative 2 on the end there makes it quite easy. So it's either going to be 1, 2 or 2, 1. Okay, because of the 5 there, I'm reckoning the 2 is going to have to go there and the 1 is going to have to go there. You can see how it works. So that way you'd have 3x times 2, 6x, and if you subtract x, and then that would work for us, wouldn't it? Okay, so let's check that. 3x squared, yep, and then 6x, subtract x, yep, and then negative 1 times 2, yep. Okay, and that's it. And then that's factorised completely. So just while I've got time, because I mentioned the discriminant, okay, what you do is just have a look at b squared minus 4ac. Okay, you just quickly work out what that actually is. So that's the b, so that's 25, because it's b squared of course, and then subtract 4ac. 4 times 3 is 12, times by negative 2 is negative 24, so subtract negative 24 is plus 24, so you get 49. Okay, what you're looking for is if b squared minus 4ac is a square number, it factorises completely. It's just a handy check for you to be able to see whether it does or not. Okay, because sometimes you can spend a long time thinking, oh gosh, how does this factorise? Just quickly check the discriminant. Okay, I'll say yeah, if the discriminant ends up being a square number, then it factorises nicely. The reason is because you do the square root of this in the quadratic formula, and as long as that turns out to be a nice rational number, not an irrational number, then it will factorise nicely. If that went over your head, don't worry about it. Okay, but that's the answer you should be getting. Okay, I'm hoping you found that helpful. Okay, this is my last example using the factor theorem. I'll save this one to last. It's my favourite. I do love doing these, to be honest. I do love a bit of factorisation with cubics. They're really great. Okay, so fully factorise this. Okay, that's all you've got. That's all you've got. Okay, notice how different it is from the other questions. That's kind of why I like it. It's more challenging. Okay, where does the factor theorem fit into this? You're not being told anything. Okay, if you use long division, what are you going to divide by? Okay, if you're using the inspection method, what's one of the factors? Okay, that's the whole point of the question. Okay, so what makes it challenging is we have to ourselves find out what one of the factors is. Okay, and just a reminder of the factor theorem. We need to decide, we need to find what a given factor is. So we need to find a value of a, okay, or a value of x, okay, such that f of a equals 0, and that will give us our factor. Okay, so what we need to do, essentially, is to try out different values of x and see what happens. Okay, let's start off with an obvious. Okay, so f of 0, clearly it's not 0, is it? 0, 0, 0, negative 9. Okay, however, if that turned out to be 0, then x would be a factor. Let me just slip on another x term there. You see, x is obviously a factor. Okay, and that would be a nice simple one to do. Okay, but it's not. Let's try another simple number. Let's try x equals 1 and see what happens. Okay, so we get 2 times 1 plus 1, subtract 18, subtract 9. Is that equal to 0? No, it's not. Doesn't matter what it is. Okay, but it's not equal to 0. In fact, it's negative 27 plus 3. It's negative 24. That's not working, is it? Okay, so we try another number. Okay, another simple number might be negative 1. Okay, I'm going through the easy numbers, notice 0, 1, negative 1. Okay, so 2 times negative 1 is negative 2, and then plus 1, and then plus 18. I hope you're happy with this, by the way. I'm doing it quickly. Remember, negative 1 cubed is negative 1, negative 1 squared is 1. Okay, is that equal to 0? No, 18, 19, 10, 8, no. That's not equal to 1. And what you do is you keep on trying values until you get an answer that works. A value such that f of whatever it is equal to 0. At this level, I mean A level or IB, whatever you want, okay, they're usually quite easy, okay? It's normally either 1, 2, 3, negative 1, negative 2, negative 3, or simple fraction, like a half or third or quarter, okay? So we've just got to keep on going. So I'm going to try f of 2 next. So 2 cubed is 8, times by 2 is 16, plus 4, subtract 18 times 2, so subtract 36, subtract 9. Is that going to work? No, because that's going to be negative 45, and that's 20. 20 subtract 45 is negative 25. Doesn't work, so we'll try negative 2 next. Okay, so that's going to be 2 times negative 8, so it's negative 16, that's going to be plus 4, that's going to be plus 36, and then that's going to be subtract 9. Is that working out for us? No, that's 40, subtract 25, that's 15. No, that doesn't work. Okay, so we'll get rid of this. And the next one let's try is 3, so let's just try that. Okay, so 3 cubed is 27, times by 2 is 54, and then that's going to be 9, that's 9, and then 18 times 3, that's 54, so subtract 54. Oh, this is looking more positive, isn't it? So I shouldn't really say more positive because that's equals 0, isn't it? What I'm saying is this looking more likely. 54, subtract 54, 0, 9, subtract 9, 0, 0. So, found it. Hooray, found it. Okay, sometimes you get lucky, sometimes it is one of the simpler ones like 1 or -1 or 2 or -2, but you just got to keep on going, okay, until you actually get to a particular value. Okay, let's rub out that then. I'll keep the last one because that's the one that worked. Let's just get rid of this, and what I'm going to then write down is that this here, f of x must factorise with x minus 3 as one of the factors. Okay. What I'm going to do is underneath this write down x minus 3 is a factor, because it just kind of reminds you really of what the factor theorem is all about. Okay, there it is. Okay, f of a equals 0 implies x minus a is a factor. So f of 3 equals 0 implies x minus 3 is a factor. Okay, and that's it. Next, what you do is you'd either use long division or an inspection method to work out the other factor. Okay, if you want to use long division, go ahead. Okay, see how that goes out for you. But I'm going to use the inspection method because I prefer it. Okay, and you should be comfortable with long division by now. Okay, so with the inspection method, that's going to be 2x squared, isn't it? Because 2x squared times x, let's write it down by here, is 2x cubed, which is our first term. Okay, if I then do that times that, I get negative 6x squared, and I compare it with what we need. We want plus x squared there, so we have to add on 7x squared, so that these two will combine to get the plus x squared that we need. Okay, so this term here, in order to get the plus 7x squared, has got to be plus 7x. Okay, you can see that because x times 7x gives us 7x squared. Okay, and then if I do that times that, it gives me subtract 21x. Let's compare it with this. We want negative 18x there, so we have to add on 3x such that those two terms will combine to get the negative 18x. So for this term, I'm going to have to use something in order to get 3x there. And bear in mind, I'm going to multiply it with this. I think that's going to be plus 3, isn't it? So 3 times x gives me the 3x, and then follow it through to the end. Negative 3 times 3 is negative 9, which is what we wanted. Okay, so you've got 2x squared plus 7x plus 3. Okay, hopefully, if you use the long division method, then you got exactly the same. Okay, you got 2x squared plus 7x plus 3. If you didn't, you made a mistake, you'd have to do it again. Okay, maybe some of you become more comfortable with the inspection method now. Don't forget, in an exam, unless it says otherwise, you're free to use whatever method you want. Okay, so if you want to use long division, go ahead and do that if you're more comfortable with it. Whereas if you want to use the inspection method, then you can do that as well. Just bear in mind, this question here says fully factorise. What that means is likelihood is that's going to factorise some more. Okay, so I'm going to just assume that it does and just try and work out what it is. Now that's going to be 2x and x, and because they're all positive terms, it makes it nice and simple. That's going to be plus there and plus there, isn't it? Okay, and because of the 3, you're going to have 1 and 3 or 3 and 1. Because of the 7, the 3 is going to have to go there, because then that gives us 6x, and if the 1 goes there, gives us the x, and 6x plus x gives us the 7x. So it just factorises quite simply like that. Okay. Sometimes a question I'm asked is this. I'm sometimes asked, if you've worked out that f of 3 equals 0, obviously that means that's a factor, that's what we did. Can you then keep on going? Can you then keep on guessing to get all the other factors? So another one you might try is f of negative 3, okay? And if you do put it in, you do get 0, okay? You do get 0. And that would imply that x plus 3 is a factor. Indeed it is, because we can see it there at the end. Yeah, and if on your next attempt you tried, for example, negative a half, and you put it in, you'd find that gives you 0 as well. Try it if you want to put in x is negative half. That gives you 0, okay? And yes, it does, because we've seen that 2x plus 1 is a factor. So my answer to the question is, yes, you could do it all completely by putting numbers in and working out the 3 factors that way, okay? But it could take you a long time, okay? Particularly if the quadratic factor does not factorise further. Because if this quadratic factor does not factorise further, then that means the numbers are pretty difficult for you to find, okay, by inspection, to be honest. Okay, so the best thing is, I would say, once you've got one factor, then just work through either long division or inspection method to factorise the rest. Okay. Well, I'm hoping you found that useful. Okay. Now, a little talk about why we're interested in doing this. Okay. Well, this is a reminder of why we bother factorising in the first place. Okay. Well, sometimes the most obvious reason for factorising polynomials is so that we can solve f of x equals 0. Okay, and it's quite quickly done, isn't it? Okay, once you've got this, if I wanted to write down the solutions, the roots of f of x equals 0, I'd write down x equals 3, x equals negative half, x equals negative 3. Okay, I'm done. Another reason is because sometimes we're asked to sketch the graph. Okay, and if we're asked to sketch the graph of this, it's so much easier if we can factorise it as much as possible first. Let's just have a go at doing that. Okay, so sketching the graph. Okay, now that we know that it's factorisable and we have factorised it, we can write down 3 of the roots. Okay, so we've got x is positive 3, negative 3 and negative half. So I'm going to put the negative half there, I'm going to put the negative 3 there, and I'm going to put the positive 3 there. Okay. Y-intercept is something we look for next. So from the original, y-intercept is negative 9. So I'm just going to put it down by there. Okay. Then we just join them together. We just join them up. It is a positive x cubed graph. So remember, positive x cubed graphs look something like this. So that means is quite vaguely it's going to look something like that, isn't it? Okay. So what we'll do is I'm going to sketch that kind of a shape. So here we go. Pass through all the points, and it should look something a little bit like that. Okay. If you wanted to, of course, you could work out the coordinates of the maximum and minimum points. That looks a bit wonky. Sorry. Okay. You could work out the coordinates of the maximum and minimum points are, if you wish. Opportunity to do some calculus if you want. Okay. Just differentiate that and find out where the maximum and minimum points are. Okay. Should we do that? Yeah, I'm in the mood for calculus. Suddenly I am in the mood for calculus. Gosh, I feel myself getting better minute by minute. Okay, I would do, yes, let's do some calculus. Okay, now that I've mentioned the C word, let's get that in there. Okay, right, calculus. So we're going to find f dash x. Okay, that is 6x squared plus 2x minus 18. Didn't that feel good? Okay, doesn't that feel good? What we're looking for the maximum and minimum points, okay? We're looking to see when the gradient is equal to 0, of course. The gradient of the maximum points are 0. So we'll look at solving this is equal to 0. So here we go to a nice quadratic to solve. Let's divide everything by 2 first of all. 3x squared plus x subtract 9 is equal to 0. What sort of answers are we going to get? Okay, does that factorise nicely? So let's go for, let's try the b squared minus 4ac, just to see if it does factorise nicely or not. So b squared is 1, subtract 4 times 3 times 9, it's 27, 54, 108, plus 108. No, not going to factorise it because that's not a square number. Okay, so it goes next into the quadratic formula, not complete the square because of the 3x squared. Okay. Quadratic formula, so you've got x is equal to negative b, so negative 1 plus or subtract square root of, I just rubbed off the discriminant, never mind, b squared 1, subtract 4ac, 4 times that times that. What did I say it was again? 27 times by 4, 54, 108, so plus 108, so that's 109. Okay, all over 2a's, all over 2 times 3, which is 6. Okay, so those are the answers. I've got a calculator handy here, always have your calculator handy. Okay, so negative 1, subtract square root of 109, and divide that by 6. What have we got? Doesn't simplify as a third, but that gives us positive 1.57. Okay, so what that means is that's got to be that value there. Okay, so that x coordinate has got to be 1.57 something. Okay, and you can work out the y coordinate if you wanted to. What you do is just put in that x coordinate into this there, it gives you the y coordinate. I'm not going to do that, but you can do that if you wish. Okay, let's try the other one. Negative 1, subtract square root 109 and divide that by 6, okay? That gives us negative 1.9, okay? So that x coordinate there is negative 1.906 something, okay? Yeah, I enjoyed that. I hope you enjoyed that as well, okay? Bit of calculus never hurt anybody, okay, particularly an A-level math student, okay? So there we go. So there we have the roots, crossing points, okay, and we've got the y-intercept and x equals 1.57 and x equals negative 1.90 something for the maximum minimum points, okay. Like I said, if you want to just spruce it up a little bit more, you just put these into that and that, and it gives you a y coordinate. You can write down the coordinates, okay. Hoping you enjoyed that example just as much as I did, okay. I'll see you again.